All right, we are gonna learn today about intro to version control with Git and GitHub. Now you all hear my voice a lot, so I like to ask other folks to just read some of the background materials sometimes. So could I actually get a volunteer to just read this first paragraph here about what we're trying to accomplish by learning this?
I'll do it. By the
Oh,
oh, go ahead.
awesome, thank you, Devin.
Oh, my bad. Oh, by the end of this lecture, you'll understand how to use the command line program Git to manage changes to a project in a way that allows you to keep track of those changes and roll them back if necessary, a process known as version control. Additionally, you'll learn how to integrate Git with the website GitHub so the changes the changes will be backed up on the internet for the sake of posterity and making it easier to visually explore your project.
Awesome, Devin, thank you, sir. And could I get a different volunteer to read this next paragraph?
I'll do
Version
it.
control. Oh,
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 okay.
Erica, I saw your hand go up first. Brandon, you're up next.
Okay. Version control software is critically important for modern software development. In addition to tracking changes and safely being able to undo work, it also lets you safely collaborate with the same code base, on the same code base with others without causing problems or conflicts for each other, and manage and share different variations of your code base.
Erica, thank you. And Brandon, if you could read this last paragraph, please.
Git is one of the most popular version control tools, and some understanding of it is a prerequisite for every software engineer, regardless of your level of experience. Git was created by Linus Torvalds, the creator of Linux, to help manage the challenges of a remote distributed team. It has become widely used, especially in the open source community. We will focus on Git and GitHub in this course. Some other version control tools are Mercurial and SVN. Learning Git will also prepare you to use these other tools if you encounter them in your career.
Awesome. Brandon, thank you very much. Thank you guys. Yeah. And so to go over the learning objectives about what's going to happen today. And actually, before I do that, let me just comment on this, what we are trying to accomplish. This week is sort of a preview of software engineering tools. And the metaphor I like is construction. If I'm building a birdhouse, I just need a hammer and a saw and a piece of paper. If I'm building a doghouse, I might need a better saw. I need more wood. I might need a bit more of a design. If I'm building like a gazebo or a pergola or something on the porch, I might need blueprints and I probably need a power saw and some other tools. If I'm building a house, I need a bulldozer. I need a backhoe. I need plans and I need, serious tools. And I can't just get in the bulldozer and start driving it. I have to learn the tool. If I'm building a skyscraper, I need massive plans, and the person using the giant crane that helps build the skyscraper can't just hop in there and do that. That takes serious training, right? And that's one of the big differences between programming and software engineering as a professional. And so this week we are getting a preview of the tools like Docker and like Git and GitHub for version control that will help us build big things. So this lesson is going to be about, we'll learn about GitHub and how to clone it onto your local machine, how to connect a Git repo on your computer to GitHub, and I'll talk about the difference between Git and GitHub, to share code from, it's called a repo on your laptop to the cloud, to get code from the cloud on GitHub, right? And we'll learn about workflow, and workflow is sort of the magic term in software development. We'll learn about branches in Git and GitHub and what they are. We'll see how to create a Git repository and to understand how to fork a Git repository and what the heck forking is. So let me go ahead and get a little warmed up here and start writing some code. Well, and actually, before we do that, let me just give a little bit of a preview of where we're going to end up. So this curriculum website that we know and love, um, the actual written content and all of the image files and everything is actually stored in a GitHub repository. And actually, I'll see about giving you all read-only access to it. And so, and we actually we'll learn about workflows soon as well, but our written curriculum, and let me bump the font size up here a bit. And this website, GitHub, is sort of like a social network for developers. And I'll be talking more about what this is in a minute, but just to kind of give a preview, we can see we've got folders and files and directories. And if we go in here to phase one and the fundamentals directory, and here's yesterday's Docker lesson, and here's today's Git lesson, and we have all these files, right? Including this what are we trying to accomplish file, which is actually just a text file in a format called Markdown that you can write in VS Code, and you've seen me writing it, and it's become really standard for programmers to use. And the GitHub website renders it to have a nice preview, but it's just text. And you can see that's why when I'm writing our sort of outline docs, we have these hash marks and dashes, and you can see there's links and other things. And so this GitHub repository has our whole curriculum, right? And this way, as we change it and update it, we can keep track of the changes that we make, just like we would with code. And we have that same repository, which I will make sure everyone has access to for demos and notes, where we can see yesterday's Docker lesson over here. And so here is the Docker file that I wrote during the lesson. Here is the shell script, and this might be good for folks to refer back to as a reference, by the way. You absolutely should be looking at demos and notes code when you're doing assignments um, and assessments. And we have this code here. So this is sort of a preview of where we're going to end up. And with these repositories on GitHub, right now you only see Markdown in there, but you can have code in there as well. And in fact, I think we have a couple software projects floating around in some of our repos. But let me show you all very briefly um, another sort of preview. Later in the course, we will learn about a library called React that is built in a language in JavaScript for creating user interfaces. It was created by Facebook. It is open source. And the reason this is relevant is because since it's open source, it means that the entire code for this library is available on GitHub. And this is how Facebook and the team manages and works on this code. And if we dig in here, it's like big projects are big. There's lots of code. So we're not, going to worry about reading or understanding this code or writing this code. I just want to kind of give an example. And so this is a lot of code, right? And this is why we need version control. And later we'll see too how with GitHub, people have conversations around issues. And in fact, let's see if I was just talking about code review. So let's in fact look at a pull request maybe that's having a lot of discussion going on. Um, let's sort by most commented. Here we go. So someone has worked on a feature. They've changed code in 5 different files. And this is why we're learning Git to see how all of this works. And we can see on the right in green the code they changed with something called a commit, which we'll learn about in just a minute. And I was talking about the importance of code review and collaboration and communication. And you can see here that, for this code that they shared requesting review on, there's a lot of back and forth discussion on the right way to do it. And this is pretty normal. And this is why there's going to be so much emphasis on demoing code and discussing it and writing it. And I just want to pause and check in and see if folks have any questions about stuff. Okay, cool. So that's a bit of a preview of where we're going to end up. Let me go ahead and get us started. So let me let's get our notes set up. And I figured we could do a little kind of command line navigation. If I use the print working directory, pwd command, I can see where I am. On Mac, I've opened up a terminal here. On Windows or WSL, I don't think it's called PowerShell, but there's a different terminal you can open. And we're going to open VS Code from here in just a moment. I'm going to use the change directory command to navigate into my code directory where I have all sorts of stuff. And if I look at the working directory, we see that that's inside my home directory. And because I know all of my files and folders, because I've been doing this so long, I'm going to navigate into the directory I have for Code Platoon and the directory I have for Corsair. And you all will probably want to make a directory named Corsair or projects or code where you can organize your work. I will eventually have different directories for assessments, and you might want all your assignments in here. And this is the directory. And in fact, it's a GitHub repository or Git repository, and we'll learn about that later for the demos and notes that we were just looking at. And let's navigate into my fundamentals directory. And then I need to create a new directory for my notes for our lesson today. So we'll call it GitHub. And if I type ls again, because I love to double check stuff, I see that that directory has been created, and I'm going to navigate into it. And we see that they're there. And now I'm going to open VS Code, but I'm going to do one extra command, which is this dot. And that dot, there we go, tells VS Code to open VS Code and have that sort of sidebar with the file explorer, what's called the VS Code workspace, be in this directory. And the dot is a very special thing on the command line, by the way. The dot is a placeholder that means whatever directory I'm currently in. So if I type ls dot, it lists whatever's in here, which is nothing. But now I have an empty file. And so if I do ls dot, we see that. If I did ls and two dots, it would list a directory level up. And if I wanted to navigate up to the previous directory, I would do cd two dots. If I did cd one dot, I stay right where I am. So the dot is not a VS Code thing, it's a shell, a Linux thing. So I'm opening up VS Code in this directory. And now that I've done that, because I added that dot, note that the VS Code terminal is right where I want it. And that the VS Code file explorer, which one of these, I think it's the Explorer. I always use on Mac, it's Command B to open and close it, Control B on Windows. So now I have my VS Code set up, right? So this is the workflow that you all will probably want to follow is you might want a different terminal and then you open it up there. Honestly, a lot of the times what I do is if I want to open up VS Code in a different directory, I'll in VS Code navigate to it, do code dot, and it will open up another VS Code. But now this one is set up in the directory I want, and I would just close the other one out. So I thought I would just throw a little bit of sort of command line warm up in there. And let's in fact use the command line rm or delete command to delete this file foo that we don't want. And I got that error because I'm not in the directory where it is because I was moving around. So I can navigate in there, or being lazy, I'm just going to right click on this file and go to open an integrated terminal. Note that I now have two shell sessions going in this terminal. If I type exit, this one will close. And this other one is where I am, is where I want to be. I'm now in the same directory as the file foo that I want to delete. And so if I type rm foo, that file is now deleted. And I'm going to create a file and we're going to name it readme, where our notes for this lesson will go. And I'm going to open it up. And when you open a file like this in VS Code, it just opens it up as a new tab. And so that was a little bit off topic, but I thought that would be a good sort of warm up for us before we dive into Git and GitHub proper. So, Git. We're going to talk about what is Git. We're going to talk about Git versus GitHub. We're going to see Git is a command line interface program. We're going to learn how to create a new Git repository, aka repo. You'll usually just hear me say like create a Git repo or repo for short. We're going to learn some key commands: git add, git commit. We're going to learn about branching. We're going to learn about checking out a branch, and we're going to learn about merging a branch. And then we will kind of, review, and there will be some advice. And the context here is every single coding assignment will have a Git repo for you to use. You will get tons of hands-on practice with Git because we've designed it so every single assignment you'll be using it. So today is an introduction, and you will have tons of practice to develop these skills over the next 15 weeks. I just want to pause and check in and see if folks have any questions before I dive in.
Got a question. It's totally random though. So right now for my setup, the window manager I'm using is i3, but I was attempting to teach myself C in order to use DWM. And I obviously DWM, when it comes stock, there's nothing in it. You got to apply the patches. Now, when they talked about, because I've seen a couple different tutorials and walkthroughs about applying patches, one of them gave just a regular step-by-step way through the command line. Another one said that applying patches via Git commits was cleaner as opposed to just trying to apply them through the command line. And I was wondering if you could break that down as why that would be.
I gotta be honest, some of the libraries you mentioned I'm not familiar with at all.
Okay.
But if we chat later, I can get a little more detail from you, and I might have to do a little Googling myself, and I can see if
Okay.
I can give any perspective.
Sounds good.
Totally. Cool. All right, let's talk about Git. So there's really two things going on here. And bear with me just one sec, folks. My OCD-ness won't let me not do this. Okay. Git is a command line tool. It is used to create a Git repository or repo. GitHub is a company and web service for storing Git repos in the cloud. Right? So if we're going to do a little drawing here, and let me get my drawing set up. I've got, and let's make this bigger. Excuse me. We'll just start fresh. I've got my laptop, and in here is where we are running Git. And then we've got somewhere on the internet, right? Somewhere in a data center, in the cloud, there is GitHub. And that's both the website that we saw, the and GitHub, the company's servers, and somewhere in the cloud, they are also running Git. So what we see here, this nice user interface in my browser at github.com, this isn't really the Git program we're going to learn about. This is sort of like a nice front end or user interface to look at what's inside one. And we'll see what that means in just a minute. And so I write code on my computer. I write code inside a Git repository, as we'll learn, and then I send that code to the internet. And we'll learn about that later. And then to tie this back to some of the big picture things we've been talking about, when we're working on a team and you have many people collaborating, once I've done that work, if you want to grab that work because we're working on the same project together, you can do that as well, right? And in fact, this really would be not just two people, but let's clean this up a bit. Potentially dozens of people, right? Especially for a big open source project like React or Linux or Google, that has thousands of engineers, or even I worked at a startup called reverb.com that had about 200 employees, and they had about 20 engineers. The engineering department was about 20-ish people split into about 5 different teams, right? And so this is how you get a whole bunch of people to collaborate on the same code and the same software. So let's start getting hands-on with Git though, so that we can kind of see more of what this is like. To do this, let's see, I need to move to a different directory because I'm inside a Git repository right now. By the way I can tell I'm inside a Git repository is if you look at my command prompt here in VS Code, you can see how it says git colon and then in parentheses main. This says this is sort of a helper utility in the shell telling me you're inside a Git repository, and the branch, which we'll learn about later that I'm on there, is called main. There are other ways to check if you're in a Git repo, but that is one of them. And so actually, I think what I'm going to do here is let's just go ahead and we will go to, I'm going to open up another terminal. I think that's going to be the best way to do it. So I'm going to go back to my home directory. Let's go into code. Let's go into Code Platoon. Let's go into Corsair. And now we can go ahead and tackle this down. So creating a Git repository. And forgive me. First, I will make a directory. Inside that directory, I run the command git init. So Git is a command line program, and I believe you all have it installed. You can check by if you just type git and hit enter, you will see all this stuff printed out. Most command line programs, you can pass an argument to it called a flag with 2 dashes, and they have one called version. You can see what version of Git I have installed. If I use the built-in shell command which, and I give it the argument of the program and I want to know where it lives, it gives me the file path to where on my file system this program lives. So I'm going to make a new directory. We're going to call it my first repo. And I'm going to navigate inside that directory. Now, I'm going to run this Git command line program. And as you all have noticed on the command line, when you're running a program, you can give it what's called different arguments, which is basically more things you type after the initial command. And so different programs have different kinds of arguments you can give them. And this one is init for initialize. And this creates a new Git repository. And so two things have happened now. One is we see that my command prompt has changed. It now says Git and then in parentheses main, telling me I'm now inside a Git repository. The other thing is, if I type ls to list all the files and directories in here, I see nothing. But if I run the list command with this -a flag, it lists all the files or directories that start with a dot. And in the shell on the command line, these are called dot files, and they're normal files and directories. It's just a convention, like a stop sign or you can turn right on red. And the shell normally doesn't print those out, and they're normally used for configuration stuff. And this directory right here, named .git, is what makes a Git repo. And we can see what's inside this directory with the ls command. I can pass ls an argument to list what's inside a particular directory. And we see there's a bunch of things in there that were created. And I can navigate inside that directory and use ls right there to see everything that's been created. And much later in the course, we will actually have a workshop that does a deeper dive into this stuff. We'll learn a little bit about config later, but we're not going to worry about it right now. And if I see my working directory, if I print that out right now, we see that this .git directory exists inside here. I'm going to navigate a level up to get outside of it, and I'm back there. Now, the beauty of a Git repository is it's just a directory with this special .git file inside it. If I decide I want to delete this repository, and by the way, let me make a file just so we can see it. If I decide I want to delete my Git repository, I can use the remove command, and I have to use the command I need to remove a directory. R is for recursive to delete all the files and folders inside that directory, and F is for force. So the RM command isn't constantly asking me, are you sure you want to delete this file? Are you sure you want to delete that file? It'll just delete it all. So be careful using this command, right? Don't use it to delete a directory or unless you're sure. And there's a classic programmer joke about deleting the very root directory of your whole file system, which that directory name is just a slash, and that would be very bad. So use this command with caution. If you're not sure, just check in with a TA or myself before running it. If you get rid of this, it will prompt you for stuff which is a bit safer, but if you're not sure, just double check. And we're going to go ahead and delete this .git directory that I just created. Notice how the command prompt changed, right? And by the way, one of the best Git commands is git status. That gives me some information about the Git repository. Excuse me, my annotator tool is getting away from me here. If I type git status here, I see this message. While it says fatal, which seems scary, all this is telling me is that the directory I'm in is not a Git repository. And by the way, deleting that .git file didn't affect any other files or folders, right? This foo.txt file is still there. I am going to delete that file though. And I'm going to create the Git repository again. And if I type git status now, the Git command line program gives us a message, right? It tells us what branch we're on, which we'll learn about a little bit later. We'll learn a little bit about commits and some other information. So I just want to pause and check in here and see what questions folks have, and what people are curious about. And this is a great time for questions because we're about to take a 5-minute break. How are we doing this far? How are we feeling on like a scale of like 3 to 6? On a scale of 3 to 6. I see a 6. I see a 6. I see a 6. Any fives? Any fours? Some fives? What about threes? I'm always rooting for threes. All right, cool. Let's take a break, folks. And I appreciate the feedback. It's super helpful, especially over Zoom with a lot of talking, but also just in general. Um, so just to kind of recap, we've learned how to create a Git repository. We've done some command line review. To create a Git repository from scratch, I make a directory that I'm going to turn into my repo. I navigate inside it, and I run the command git init to initialize or create a new repository. And what that does is it creates a special directory named .git inside that directory. And that's what makes this directory a Git repository. And now if I use the Git command line program to type status, I see some information about that repository. If I realized I don't want this directory to be a repository, I can just delete that .git file. And in fact, let's go ahead and just delete my second repo altogether. And if I type git status and I see this fatal message, it just means that the directory I'm in is not a repository. When we come back, we are going to get into Git commands to start doing stuff with Git and files. So let's take a short 5-minute break, and I'll see you all in 5 minutes. Thank you. All right. So we saw how to create a Git repository, right? We just make a directory and run this git init command. We really haven't seen what's the point of Git or what does it do yet, right? And we're in a moment, we're about to run some commands to do that. And over here, I do want to navigate back into that my first repo directory. So I had moved out of it in my shell session. So I'm going to navigate back inside of it. And again, we see this command prompt has changed to help remind me I'm inside a Git repository. And if I type git status, we see this message on branch main, no commits yet. Create copy files and use git add to track. And this is exactly what we're going to do next, is using git add and creating and copying files. But why do we want to do all this work? Well, to help illustrate that, I wanted to use Google Docs. If the doc will let me log in. Here we go. Why version control? So version control is really straightforward. And I'm just using Google Docs to kind of illustrate the principle. If I go in Google Docs all the way down here to version history, I do see version history, I can see the changes that happened to this document, right? And I can, maybe I want to name this, and I want to say this is, my initial commit. We'll call it version 1. And then we might be collaborating together and we make some changes. And someone else might say, like, I disagree, it's raining over here. Whether we're collaborating on a doc or it's just me, either way, and I'm sure at some point you all have done this and working on a paper or some sort of document at some point, it's nice to see the different versions of things that you have. And truth is, well, this is nice, sometimes I'll have like multiple Google Docs, and I'll just, when it's time for me to make new changes, I'll just, like version 2 or, the changed better version. And has anyone ever done that where you're just making multiple copies of a doc as you work on it and edit it? Yeah, everyone has. I see a bunch of nods, and I know that like even the people not raising your hands have done that. So that's a great example of the value of version control. Like, and since programmers love writing software and systems, we don't want to do that manually. We want to write software to help us do that. And that's sort of our end state with Git. And to get there, we're that's what this is all about with adding and tracking files, but we do it really granularly where we control which changes we track for what version, right? And so inside a Git repository, every single file, and forgive me, I don't know why this TL draw keeps getting smaller. Every single file is in one of 3 stages. And we'll put this here and let's sort of bear with me a sec here. All right, there we go. Right? My whole Git repository has a status. And there's a couple possible statuses. The first one we're going to talk about is untracked. And to do that, and let me get a little real estate here. So let me just kind of move things around a bit. There we go. And is that font size still readable to everyone? Perfect. Thank you. So let's create some files that we're going to help keep track of the changes that we make to them. I'm going to use the touch command to create those files. I can actually use it to create multiple files at once. So I'm going to create a file named example.txt, example.py, and example.js. So I'm passing the touch command 3 arguments, right? And each is the name of a different file I wanted to create. If I type ls, I see that those files are created. And to open them in VS Code, again, it's really normal to be able to pass command line programs multiple arguments. I'm going to use tab to help autocomplete some of this for me. And we're going to open up our 3 empty files. And we're going to write some code in here in just a minute, but I want to type git status first. And now we see something interesting. We see this message over here that says untracked files. Use git add to include what will be committed. Right? So we now have 3 files in our repo that Git says are untracked. And what that means is I can change these files. I can delete these files. For example, let's just delete example.js. And if I type git status now, we see this. And let's create example.js again and open it up just so it's there. The Git version control program does nothing with untracked files. From Git's perspective, it doesn't care about those files. It doesn't worry about those files. We're not getting any sort of saving or version control benefits from it. But all work starts out untracked. So what I can do now, and again, let me type git status so we can see the status. What I can do now is what's called adding a file. So this is another category that a file can be in Git. If a file or a change to a file can be untracked, or it's called staged, aka added. And you'll hear people say both, and you'll see the command line say both. And this is sort of like, again, to go to the baking metaphor, if I'm making cupcakes, if I add a file, it's sort of like the cupcake is in the muffin tray or whatever, but it hasn't gone into the oven. It's not baked yet. So if I do git add example dot, and actually let's put some messages in our files. So in example.js, let's add a print statement and just say hello world. In example.py, let's add a print statement and say hello world. And in our text file, let's add a print statement and say hello world. And before I add this file, let's just type git status again, just to see if it says anything interesting. And it still says the same, right? It doesn't know, it doesn't care. These files are untracked. So let's go ahead and now let's use the add command to add example.js. Now, if I type git status, we see it says changes to be committed, new file. It's starting to pay attention to this file. We'll make this blue. By the way, Git also, or VS Code also does have a sort of sidebar tool for looking at version control. Like if we look here in this my first repo directory, we see there's changes that are untracked. It says staged changes, and we see example.js over here. There can be some value into this. We really want you using the command line to start out. It's a bit simpler, I think, but also it's really important to become comfortable on the command line, right? I know a lot of really expert programmers who are far from command line wizards, but they all are comfortable there. So I think it's just really important to start with Git on the command line. So I have added this file and it says it's ready to commit this one, but these ones are unchanged. I could add my other files as well, right? If I did git add example txt, I could maybe add them both together. But a lot of the times you might be changing a bunch of files all at once and you want to save all that work together. So there's a shortcut, which is git add space dot. Can anyone remind me what the dot means in the world of the shell and the command line?
That's a directory.
Which directory?
The parent directory. No, not
Close.
the parent, not the parent. The previous directory.
Close. 2 dots is a level up. The 1 dot is the directory we are in right now.
Oh, sorry. You're right. Current working directory.
Yeah, but no, you're on the right path. And I love it, Devin, because you jumped right in, man. Thank you. So what I'm telling Git to do is add all the untracked files in this directory. And if I type git status, we see that these are now all added, right? So we can already see how, again, think about learning how to use the big crane they used to build the skyscraper. This is a lot more complex than Google Docs version control because we control all of this manually. So now all of these changes, these files are added. It's called being staged. Now we get to do the fun part, which is called committing. And the command is git commit. Most of the time, I recommend when you run this git commit command, you use this flag -m. I would say just do this all the time right now for simplicity. The reason is if I run git commit without the -m, it's going to open up either a tab in VS Code or a text editor in the command line, where it's going to ask you to write a commit message, like you see here, where it's created a sort of temporary file these lines that are all commented out with this pound sign don't actually show up. And if I was to do this, I would type the commit message, and then when I save it, the commit would be made. This is good sometimes, but it can be a little bit of a pain in the butt in the beginning. If I do git commit -m for message, I can just in single quotes or double quotes write a short message on the command line, and your workflow is much easier. So to create a commit, git commit -m and add a message to remind yourself what's in here. And we'll just say my first commit. And we see this cool little statement, 3 files changed, 3 insertions. Now, if I type git status, I see something really interesting. It says on branch main, working directory clean. Right? So the final and third category that anything can be in a Git repository is committed. Right? What's the joke? The chicken cares, but the pig is committed to breakfast or something like that. Does anyone know that one? Like, I don't remember it exactly. It's like, the chicken cares about your breakfast, but the pig is committed, right? Because, the pig gets turned into bacon. So we have now committed this code in Git, and the files are still there, right? The beauty of Git is it works with the file system and the command line. So all of these files are still files. This directory, my first repo, is still a normal directory. You can open it up in the VS Code sidebar. I just have this one just opened up to a different Explorer directory because this
Um,
was the other directory where I started. But so these are all just normals and files and directories. Git works with normal files and directories, but it helps us keep track of them, right?
I got a question.
Yes, sir.
So it's actually two-part question. So first part is the whole demo you just did, just to make sure I'm understanding. So the original files, whether it be the text files or the program files, are still on are still on your actual local system in the folder.
Correct. Everything
And
is still in my file system in the same spot that it started.
okay, and that is, and as far as the get status part, that when it's untracked, that's considered being in like on your local system. Staged is when you add it, or is when you're getting ready to add it to GitHub itself, and then committed is when it's actually on GitHub.
Not quite. I like where you're going. We haven't quite gotten there yet, but you actually touch on a really good point. So I'm glad you mentioned that. Let me kind of go way down to this diagram that we were looking at before. And this is actually a really valuable point, Devin. And let me go ahead and let's all this stuff that we've been talking about here with Git and Git status, everything is running in the Git program on my laptop. And
Okay,
yeah, we're gonna see how to send code changes from my laptop to the cloud to another Git repository. Without going too deep into it, when Git was originally created, the idea it was called like peer-to-peer, where it's not just to the cloud, but maybe like if we're on an open source team together working on Linux and you have a Git repository and I have one, I can send you my code. The command we'll learn a little bit later is git push, and that will send code to GitHub in the cloud. But even
okay,
when we do that, the code will still be on my computer. So the beauty of the Git program itself is that even if it's just me on my laptop, I can still use it to keep track of versions of my software and all those things.
okay. And the second part of my
Mhm.
question is, again, like I said, just to make sure I'm understanding you correctly.
Yeah.
Would it be safe to say that GitHub is like another form of redundancy as far as being able to keep backups?
Yeah, 100%.
Okay.
Yeah, right. Because if I drop my laptop walking across the street, it doesn't matter. how awesome I was using Git on my laptop. My laptop is ruined. And that's exactly it. We'll see how to then also use Git to send the code to GitHub so it's backed up somewhere else.
Cool.
Yeah, great question. Cami, I think you had a question as well.
Yeah, I was just wondering, so I know when I think it might be for the push though, when you like commit
Hmm.
on the command line, do you have to like have a message? Because I know I've been using the thing in VS Code, the like little sidebar thing, um, for
Hmm.
myself. And I know you like have to put a message in order for it to go through. Is it the same thing when you use the command line?
That's correct. You have to have a commit message.
Okay.
Um, yeah, that's a great question. And the reason is if I type git log, I will see a history of all the commits that I've made. We only have one right now. And we can see that there's some automated information here. There's a unique identifier of this commit called hash. There's the information, the name and email, the person, the date, but then the message that I had. And the Git program, um, it there might be an override flag somewhere, but you're always going to want to write a message. So the easiest way on the command line, I think, is just dash M. If you don't do the dash M, it'll like I can't commit now. It'll open up a tab here in VS Code, and I'll demo that in just a minute. But yeah, you need a message. Yeah, great question. And the good news is you'll actually want messages. It will end up making your life easier. Yeah, great questions, guys. What other questions do people have? What else is on people's minds about Git thus far, whether it's with Git or commits or anything else?
I think I'm
I,
understanding just about how this whole Git thing works. Um, but for my, just to be completely clear, whatever stuff you add to these files, like the PY, the text, and the JS, they're always going to be saved in your computer. And it's not until you do all this other stuff with the untracked, stage, and committed that eventually, once you this gets pushed into into GitHub, that's when, like you said, if you're working with a group or whatever, they'll be able to see the changes that you made and they could open that file and then they'll be able to make changes. And again, the changes will be on their files in the computer, but unless they do the whole process, all of us won't see the updated stuff. Is that kind of like,
Exactly.
okay,
Exactly. And that's the beauty of it. Like everything I've done right now is still just on my laptop, including committing.
okay,
Um, all of this work that I'm doing is just editing files on my laptop, on my file system. And then when I type git commit, we're using the Git directory or the Git program to help keep track of stuff on my laptop. And in fact, if I went ahead and I remember we have this .git directory, if I deleted that, well, Git status doesn't work, but those files are still here, right? So Git is sort of like it doesn't mess with the files, but it helps us keep track of the changes we've made to them. And we'll kind of see more of that in a minute. And let me, in fact, go ahead and recreate the repo and let's do git add dot and let's do git commit. And without the dash M, we see it opens up this tab here and we'll just say my first commit. And I have to close this. And now if I type git status, we're kind of back to where we were. And let me go ahead, let's add some changes. And then we'll take a break.
I had a question,
So,
Adam.
oh yeah, please.
When
Thank you.
Devin brought it up, I didn't really think about it until now. Obviously, these files are super basic and not going to take up much space. But when it comes to GitHub, is there like data limits as the complexity of the files gets more complex and bigger? Because I just think about a repository. It's obviously an area that do you ever hit a data limit for what you're able to leverage with GitHub?
Yeah, that's a great question. Let's see here. How many megabytes of text is book? So text is tiny. In terms of how things are stored on a computer, there's bits, there's a byte, which is 8 bytes, a megabyte, which is like 1,000 bytes. And then these days you have gigabytes, which is I think 1,000 megabytes. I feel like it's more than that. And my laptop, my MacBook,
1024.
what?
1024.
1024. Yes, sir. Thank you. Yeah. And my MacBook Air from 2020 that I'm on right now, my work machine has like 512 gigabytes of storage. So like a whole book, just the text takes up like 3 megabytes of space. In fact, how many megabytes? Yeah, let's see. Yeah. Oh, it is 1,000. I get yeah, 1,020. Oh, depends on the manufacturer. Okay. Anyway, point being, text is tiny. Um, Even a code base with tons of code, all this code is just text. It's not going to take up a bunch of space. These days, storage is cheap. You can upload images to GitHub. You can upload videos. Now, videos start to take up more space, right? Videos get big. Um, Unless you're uploading a very large file like the census data for the whole United States, you're not going to have to worry about storage limits on GitHub. That said, you absolutely can, and sometimes people do put like images and videos there, like for a curriculum repo. But if you have tons of images or videos, it's not the right spot. And by tons, I mean hundreds to thousands.
Gotcha. And then the other one just kind of related to when you're working with TL Draw. Is there anywhere that we can pull some of these? I know not every visualization needs to be kind of referenced back to, but is there like a key visualizations? Because for me, I learn really well with this kind of
Yeah.
aspect. Um,
I apologize I didn't do this yesterday. I usually try to take screenshots of these. And actually, speaking of uploading images to repos, I add the screenshots to the demos and notes repo. So I'll make sure to grab today's and put it in. So when you go to demos and notes for today's lesson, that screenshot will be there. The good news also is like if you take a look at our lesson in the curriculum, I'm pretty much, in fact, not pretty much, I do my best, though sometimes I go on tangents to follow it top to bottom. And in fact, all the code that I've been writing is straight out of this. And in here you will find a lot of very useful diagrams exactly like you're talking about.
okay, yeah, yeah. Okay,
Yeah.
that's awesome. Thank you.
Yeah, but absolutely, especially as we get deeper into the course and I'm making diagrams that aren't in here, I'll be screenshotting them and putting them up. And if I forget one, please do let me know because I can always go back and do that. Yeah, great question. All right, speaking of diagrams, let's make one more change here and then we'll take a break. So we've made one change. I have one commit. Let's make another commit. And this is, let me show you, this is where Git gets cool. I'm going to modify my text file. I'm going to modify my Python file. I'm going to modify my JavaScript file. If I type git status, we see that Git is saying there are changes to files that I'm paying attention to. It says changes not staged for commit. So untracked, or we should maybe say unstaged. And let me go ahead and copy these. And we're going to put this over here. And these aren't new files, but changes to the files. And there's a great command, which is git diff. And let's use it for example.js. And what we see over here in red is what is from the last commit. And the changes from, or excuse me, the changes that I made to the file that are not committed and tracked. So I can see the difference between the version that Git has saved, the commit, and what there is now.
Adam, real quick.
Yes.
You just answered my question from before, and I don't even think you realized it.
Oh,
well, when I asked you about when I was talking about when I was talking about the that other window manager, DWM, it just made
Got
sense now because what you just did when that git diff, that makes sense that why people now say to use git to apply the patches as opposed to doing the manual, because if you do the git diff first, you can see what, like, as far as like what the source code was originally and what the patch is going to change in the source code. So instead of having to apply it and potentially messing something up, you could just go in to the actual source code and just apply the changes manually.
Nice. Nice. Yeah,
So
and you
thank you.
can see, like, if I type git diff just by itself, I will see the changes to all of my files. Um, and so again, I see here in red the commits from before and the green stuff here as well. Yeah, and Devin, I'm glad I'll definitely hit you up after the lecture because I want to learn more about the libraries you're working with. Um, and so I wanted to add some changes because what we're going to do is we're only going to add one of these changes. Actually, let's add two of them. Let's add example.js and let's add example.py. And so now, if I type git status, I see a really interesting status message. It tells me I have staged or added these changes, but not this one. So as I'm working on something, if I have like a function I've written or a feature or something, and I feel like this one's done, but there's other code that's not ready, I can choose just to commit just a part of it, right? And this is the value of the commit message. And so now I'm going to type git commit -m, and we'll say changed JS and py files. And now if I type git status, those other changes to example.txt are still there. And now, here, let's just delete that for now. Excuse me, the tail draw is fighting me here. And now these even more changes have been brought over here. And let's make these red just so they're a little different. I will come back to those in just a second. And let me type the clear command to kind of clean up my console. And if I type git log, I see I now have two commits, which is pretty cool. And we'll talk in a little bit after the break about what that means. And we see the message and we see the unique commit hashes. And in the spirit of diagrams, and we'll definitely have a lot of diagrams with Git, we now have you'll often see circles used for commits. So I'm going to make one circle that's going to be the first commit, right? And just sort of as a visual aid, we'll take these files that are our first set of changes and we'll put them in here, right? And we'll call this, my first commit. And what is the commit hash? I don't know, BBF3 something, something, something. And this is the one that we made first. And now we've made a second commit. And let me type git log so I can see the commit hash. And this one is change JS and py files. And it's 86F, whatever. And what the commit tracks isn't creating these files, but it was changing it, right? And we'll learn later, like how commits connect. I'm going to draw a backwards arrow for now, but we're not going to worry about it too much. And I can look at the difference between these two commits. If I copy this whole unique ID called a commit hash, and I type git diff this, I see the difference between the commit I just made and the previous one. And we haven't gotten to GitHub yet, but we will. And for instance, here in our curriculum that Francisco has made tons of awesome changes to. When we see how to push these changes up, we can see all of these changes to the curriculum, and it's really helpful to keep track of stuff. And if I want to see like one particular change, we can go in right here. And this is just like what we were doing on the command line, but with a much nicer visual interface. Right? And so this is sort of our end state. And there's definitely more to explore with Git. And I apologize, I may eat into some of our work time because there's a couple other key concepts after the break that we're going to cover with branches and merging before we get to GitHub. But this is sort of the heart of it right here, right? Because just like with Google Docs and different versions of a file, I now have really strong manual control, right? And so let's in fact add that example.txt file because we want to commit that one as well. And at this point, you know, kind of having all this here is starting to be a little less useful because we now realize it's really this commit history that we care about. And we'll make this orange. And let's commit that. And we'll say commit-m changed text file. Now, if I type git log, I have 3 commits, right? And in the interest of time, I'm not going to worry about grabbing the commit hash for that most recent commit. But I am going to keep building up our commit graph, as they call it. And this is change text file, right? An example.txt goes in there. And I'm going to just give us a little room to work here. There is actually a great VS Code extension called Git Graph. And if I go to view, and we'll take a break in just a minute as I realize I ran a bit long over the hour here. Let's go to extensions, Git Graph. I definitely recommend installing this. You won't need it a ton, but it's a good one. If you search for Git Graph in the VS Code extension sidebar, it is the first one with the 13 million installs. And in fact, let me open it up, and it's hiding somewhere here. I believe if I go here, nope, that's in fact something else. Give me a minute just to navigate to. I don't use this part of VS Code a lot, and as you can tell, I've installed way too many extensions. So I'm getting a little lost in the sauce, but if we go to source control. So there's a couple, actually, the better way to do it, because actually this is good to see with VS Code. In VS Code, if you do on Mac, it's Command-Shift-P. On a Windows, it's Control-Shift-P. This is called the command palette. And if you hit escape, that will close. And it kind of lets you give all sorts of different commands to VS Code, like running the Git graph extension to get a nice visualization of our commit history. Right. And so here, in fact, we can see, I see this is looking at the wrong. I see what the problem is. I apologize. Bear with me one moment, folks. This is going to get a little messy, but we will make it home. I promise. The problem is that I had the VS Code opened to that demos and notes repo, and that was like where the sidebar was and the other things were. And so that was the Git repository that Git Graph was looking at. I've now opened another VS Code window that is right where we want inside the My First Repo directory. And this is how you should always do work on assignments. Always take the time up front to get VS Code open in the Git repo you're going to do work in. And now if we do Git graph, we see a nice visualization of our Git commit history, right? And we see our messages. And in fact, we can even, and under the hood, we could see all this stuff on the command line. This is just sort of a nice visual tool. We can see all of those changes. And that .vs code directory, VS Code likes to make sometimes, and we're not going to worry about that. And now if I type git status, it says everything is fine. I have my files. Here's the cool part of Git, and then here's where we'll stop for a break. Let me go ahead and delete a file. Git is telling me that a file is deleted. That file is gone. I did delete it. There's also a very useful message here on the command line that says git restore, and in these sort of brackets, it's telling me to use the name of the file to discard changes, right? So I changed the repo to go back to our visualization over here. I have, in fact, deleted example.js. And from Git's perspective, this is a change to a file just like any other change. And what I can do is, let's say I realize I made a mistake. I can do git restore example.js. And now I have it back. Right? So Git is a really nice backup tool as you're writing code. Because if you have your code working, but you want to try something new, but you don't want to mess up your nice clean code that you know works, you can use Git to try something out. And if you realize, you know what, this isn't working, my code is a mess now, you can blow all that stuff away and go back to your nice clean version of the code. So let me stop here. Let me see what questions folks have, and then we'll take a longer break.
Oh, I don't have a question. I was just going to show this real quick. This is a book that I picked up not too
Oh,
long
can
ago.
we?
It's called
Oh,
Command Line Git.
mhm.
And I have the PDF of it, and it is super detailed. And Brandon, when
Nice.
you made the comment about learning visually, it's got a lot of pictures and a lot of visual breakdowns. So if anybody wants a copy, just let me know and I'll upload the PDF to the chat.
Awesome. Yeah, actually, if you can just go ahead and drop that in course the PDF in Corsair questions, Devin, that would be awesome.
Got you.
Yeah, much appreciated. That sounds awesome. And thank you for sharing that. I realize I threw this git restore at you, so I do want to see if folks have questions before we break. Yes.
Quick question. Once you do the delete, how long does it stay there? Does it stay in on track the entire time, or or does it get lost eventually if you session out?
Yeah, great question. And by session out, you mean like closing VS Code or whatever?
Yes.
So the beauty of Git is it works with your file system. So the reason that I can delete example.js and Git knows that it's deleted is because somewhere inside that .git directory, when we ran .git init, we're not gonna dig into it, but somewhere inside there, whenever you make a commit, there's a text file with that change sitting there in your file system. So I can close VS Code completely. And let's navigate up to find where I created that repo. And in fact, I don't even need to be in VS Code. I can be now for Windows WSL people, make sure you're in WSL in Linux. That's the one tricky point here. But if I type git status, we see the exact same thing, right? Because it's all on the file system. I turn my computer off, I turn it on, no problem. Let's open up VS Code. Let's say it's tomorrow. I'm coming back. I type git status religiously, like after every single git command I run. I look at that, I realize, oh, I made a mistake. And you know what? I'm getting a little tired of seeing this VS Code directory pop up all the time. I'm going to make what's called a git ignore directory. that will tell Git to ignore that VS Code directory because this is a bit of a pain. We see deleted, we see untracked files, Git restore example.js. Now I have that back. Git status, right? Let's git add, git ignore. Let's git commit, and let's say created git ignore to ignore annoying VS Code configure that is not part of the code base. Right. And so now if I change my mind and I want to get rid of that git ignore file, it's in kind of one nice clean commit. So that's the beauty of Git and GitHub because it works with your file system. It's there forever. Yeah, great question. What other questions do folks have? What else is on people's minds before we break? All right, let's take what do we want to do? Let me pause the recording and then we'll figure it out. After the break, we do have a bit more ground to cover. There are a couple things I haven't gotten to with Git that we do need to cover before we get to GitHub. We need to talk a bit about branching. We have commits, but you can have different kinds of branches, and we'll see how to work with those branches and how to combine work from branches, though you won't have to do this a ton. So we'll look at that after the break, and then we'll switch gears, and then we will see, now that I know how to use Git on my computer to help keep track of my code, how do I share it with other people? All right, let me go ahead and stop our recording. All right, so we've been covering a lot of ground, right? We saw how to use Git to save and track files with Git status, Git add, Git commit, Git diff. We've then seen with Git log, I can see a history of all the commits that I've made. And we actually had a really good discussion highlighting the fact that the beauty of the Git program itself that we use on the command line is that all of this that we're doing is happening on my laptop, right? On my computer. None of this is about sharing code to the cloud or GitHub or to other people yet. And we've seen how when I'm making changes to a file, right? When I change something, it is untracked. I use the git add command, it becomes staged. I use the git command, the git commit command, and whatever I've staged becomes committed. And when we do that, it creates what's called a commit, and how under the hood, Git is sort of connecting these commits together, and that's how it keeps track of individual changes and lets us kind of go back in time. And in fact, I had a commit here to create this git ignore file, which was sort of an icing on the cake thing that's a little outside the scope of today that we don't have here in our diagram. So let's just add it. Create git ignore. And we saw how if I install the git graph VS Code extension and I use the VS Code command palette, Command Shift P on a Mac or Control Shift P on Windows, I can, and you can navigate through this with the arrow keys as well, get a visualization of the history of my commits to help me kind of understand Git. And we'll have an assignment that has a very visual element as well. Next up, we're going to see how Git is not just about tracking changes to files and making commits, but it helps us really easily have different versions of code with branches. So branches. Branches are a way to have different versions of the same code. Under the hood, Git is still storing everything in that .git directory. You will not need to use branches that much right now. You will much later for group projects. And branches are key to collaborating together with Git. So the git checkout command is what we use to work with branches. And if I type, well, there's really two commands, excuse me. If I type git branch, I see this weird little list. I see it says star main. I see this end here. You'll see a lot of command line programs work this way. Sometimes if it's printing out a lot of information, you can hit spacebar to kind of paginate. But when you see this, to exit this command line program running in your shell, you can just hit the Q key for quit. When I type git status, we see this message on branch main. And over here, we see this message main. Right? So let's say I want to work on a new feature and I'm going to write a lot of code for it, but I don't want to mess up the code that I already have. Right? And let me get a little room here to work before we begin and just sort of bring this up. I'm going to create a branch. So use branches for experiments or when you want to change your code, but make sure you still have a previous version that is easy to go back to. And we'll talk about like collaboration workflows with branches later. To create a new branch, or what's called check out a new branch, I use the checkout command. So I'm telling Git to create a new branch, and we are going to name it my feature. And note how on the command prompt this has changed to my feature. And if I type git status, it says nothing to commit, working tree clean, right? And if I type ls, the files are here. Everything is the same. If I open up the file explorer, all this stuff is the same. Let me just adjust the size here a little bit so we have a little more room to work. Right, and so far nothing really has changed. I am going to change our diagram a bit. And I'm going to make this diagram of our commit history smaller so that we can see it more easily. And I'm going to add the branch names. And let's do this all in red. All right, and the branch that we've been working on so far is called main. And this is what's called the default branch in Git. And the default branch will either be named main or master, depending on the configuration of GitHub and the Git repository. Most teams now use main as the default. Now that I've created my new branch, it doesn't have any changes yet, but it exists. And if I type git branch now, I see two things listed. The two different branches, main and my feature. And my feature is now in green with the star. And I can use the checkout command to switch between branches. right? And in fact, if I use dash, it goes to the last branch you were on, which can be kind of useful. So let's write some code for our new feature. Let's create an awesome feature in Python and an awesome feature in JavaScript. Right? So I've added those new files. If I type git status, we see that they're there. I'm just going to write awesome feature just for simplicity and time. And let me open these up in VS Code. And let's just, let's say X equals this feature is great. And let's print X. And in our JavaScript file, let's do the same thing. And I put them in the wrong spot because I'm seeing these red squigglies here. And I wrote the JavaScript code in the Python file and the Python code in the JavaScript file. So let's go ahead and put these where they belong. And now the world is right. And let's go ahead and git add with the dot to add all the files or all the changes in this directory. And let's go ahead and commit. And we'll say awesome feature. Right. And now if I type git status, we see branch my feature, everything is clean. And if I type git log, as we've come to expect, when I see the history of all of these commits, the new awesome feature is there. Right. And so if I'm adding to my visualization, we now have on this other branch, and we'll see why in a minute this matters, my awesome feature. So here's why branches matter and why I'm drawing this diagram that has these two rows. And by the way, if we also use the git graph tool with Command Shift P, we can see that it's sort of here, and we could look at just one branch. Or if we look at main, we see it doesn't have that feature. And this is where it gets interesting. Because on the command line, what I'm going to do is switch back to the main branch. And here's what I want to point out before I switch back. Let me grab our annotator. Look at the files listed here. Look at the files here, or the files we added, the awesome ones. Watch what happens when I switch branches. And remember, my git status says everything is great. Those files have disappeared, right? Git has actually changed my file system. What do you guys think will happen if I go back to the my feature branch? They come back. Right? So this is the cool thing about Git. Under the hood, in that .git directory that got created when we created the .git repo, and if we go in here and we poke around, and it's probably somewhere in, what is it, objects? Who knows? I don't actually know where this stuff is stored. Somewhere in here. I'm not going to try and poke around and find it. But somewhere in there, every single change I've made to a file is tracked. and saved. And maybe it's in Git objects. Let's see, where in .git there are changes saved. Objects or index. So somewhere inside this .git objects directory, it might be compressing the information or something, but every single change I've made to these files, because it's all just text at the end of the day, is saved. And so the beauty of Git and the commits, if my code is committed, it's totally fine that Git is changing files in here. Because those changes have been committed and saved. So I can have an experiment, I can work on a new feature on a different branch, and if it works, great. But if I, paint anyone ever like painted yourself into a corner writing code and like messed up something that you had working? And if not, trust me, you will. And the beauty, Tiffany, I appreciate the hand. I saw one or two other hands as well. And the beauty of this is if I do that while I'm working on my feature, and I've not just messed with these codes, but maybe I've messed with the code that I care about. Maybe I did, X equals, I don't know, right? I did something like really, really wrong. Right? And if we go back to our diagram on my feature branch, though the branch is now stretching beyond, we have our bad code. Right? And I'm going to check and I'm going to take git status. Well, watch what happens when I go back to the main branch. That code is gone from that file. And it's because I committed it, right? If I hadn't committed that code, Git would not be doing this. And so that's the beauty of commits and Git and GitHub. Now, you guys are not going to have to worry about branches, and frankly, you shouldn't right now. We just want you to practice using Git, period. Frankly, using different branches is probably going to be more confusing and challenging, and you're just going to want to do all the work on one branch. But hopefully this illustrates some of the power of this tool, right? We're building a skyscraper and what it can offer when we talk about version control and controlling and managing the different versions of our code that we have. So I want to check in here and see what questions folks have, what people might be curious about, what is good to review and go over, because this is sort of a key concept.
I know fork is for GitHub specifically, but like, how do you know when you're basically approaching a project or a problem set when you're starting whether or not you're gonna ideally use a branch versus like just doing an entire fork? That makes
Yeah,
sense.
we'll talk about that later. The way to think about this is branches are when you're working with a repository, and a repository is one project. And that's what all of you are going to be doing. Forking is when you want to make a totally different version of that project.
Perfect.
And we'll actually see how to use forks for like assignments. We're going to actually have you do that because every single coding assignment is a GitHub repository. And I don't want you all pushing code all onto the same repo because that would be super messy, right? You should each have your own. So you all will actually fork, but then you each will have your own, coding assignment for repository that you're working on. And then if you want to make a branch to do an experiment or to have a backup of your code, you can. And it's just on your repo for your copy of that project. You see what I mean?
Yeah. Okay. Awesome. Thanks, Adam.
Yeah, great question. Great question, Brandon. Thank you. Great question. Yeah, well, we'll see that a bit more later. Yeah, what other questions do folks have? What else are people curious about? On a scale of like 9 to 15, how are we feeling? Like a 10, maybe 11? 10. I saw a 10. That's good. I see some 10s. I see an 8. 8 out of 9, 8 on a scale of 9 to 15. We're at an 8. Okay, I dig it.
9 to 15. I thought you said nine, from 1 to 10. Sorry. I
No,
missed
no,
that.
no. I no, well, I appreciate that. That's even better than I thought. I do sometimes throw out like ridiculous scales on purpose, just to wake us up. Um,
I
no,
threw a
I really
12.
appreciate the feedback. Say that again.
I threw a 12.
12. I love it. I saw Jake a lot of figures up there. I wasn't sure what number that was.
It was a 12. I was trying to do like a 1 and a 2. I don't know how you guys were
Oh,
viewing it.
I dig it. I understand now. Cool. Okay. Yeah, good deal. And again, the good news here, folks, is every single coding assignment is a GitHub repository, and you'll be doing multiple coding assignments or at least one a day every day for the next 15 weeks. You will get tons of reps and sets on Git and GitHub fundamentals. And in fact, you probably will not be using branches for, well, we have a team exercise where you do, but for most assignments, you don't need them. They will show up again in group projects. So I just want to emphasize this is an introduction. We're going to be getting tons of practice on this. There's one more thing I want to show with relation to branches, and then we can stop and we'll do some work time, and we'll find a time to cover the second part with GitHub because I realize I've ran a bit long here. The last thing with branching is what we call merging, right? And by the way, in VS Code, if you just do Command P or Control P by itself, you can search or use the arrow keys to move through various files that you have opened or sort of in the VS Code workspace. And so we've covered this stuff, right? We covered checking out a branch, merging a branch. Talk about what this is. Merging is how you take work from one branch and combine it with another. It is used both when you are writing solo code and you have multiple branches, but mainly it's when you are collaborating and teammates have branches with different features that need to be combined. So, for example, with my awesome feature that I'm working on and this really terrible code that I wrote, which, where did it go? My terrible code was in fact an example.js, right? And let's say that, and let me type git status. Let's say I'm working on my feature branch, right? And I fixed my bad code. So I realized that I meant this to be, I don't know, the year 2026. And I realized I meant to print out a message saying what year it is. So I'm working on my feature branch. I type git status. I type git status before every single git command that I run, and you guys should as well. I fixed my code. I type git add, right? So again, now we're making another commit here. I'm just going to call this fix, right? And it was untracked, and now I've added it, and now we commit fix bad JS code, right? And that's become committed. And our graph grows ever longer, though this is still all inside the computer. And now I've decided my feature's ready for prime time. I want to merge it onto the main branch for the rest of the team to see and to deploy it live to our application. So I need to combine this feature branch with my main branch. So the way I do this is I go back to my other branch. And remember, you can type git branch to see a list of the branches. And I check out the main branch. And I want to merge my work from the feature branch to main. Right? So over here, I have main, and I'm just using boxes for everything because boxes are simple. And I'm going to merge onto main from my feature. Right. And so the way that we say this and the way that we do this is, first, so right, merging my feature onto main. So first git checkout main to get onto the main branch. And then I type git status just to double check everything, and then git merge my feature. So I already checked out main. I'm going to type git status to make sure I am where I think I am. I'm going to do git merge my feature. And we see this message. We see fast forward. We see some information about files that have changed. And now on the main branch, if I type git log, we see that the main branch is now keeping track of all of those commits. And the nice thing is the feature branch is still there. So I haven't deleted anything. I haven't lost anything. I haven't gotten rid of anything. Because of the way that Git keeps track of commits, right? A commit is a change to a file or many files, and it keeps track of all these things. Effectively, what we've done is just, it works a little different under the hood, and I'm not going to get into that right now. But in effect, so close. In effect, what we've done is this, right? The feature branch is still there. It still sort of connects back. But we've sort of made copies of those commits so that main branch has all that stuff. So now if I did decide to delete my feature branch for some reason, then we would still have all of that work on main. And you're not going to have to do a lot of merging right now, so I don't want you to worry about this too much, but this is the last key feature. So I just want to pause and check in and see what questions people have before we take a look at the assignment for this and do some work time.
Yeah, I got a question. So about what you just showed about the having the work on the my feature branch and then merging it with the main in whether it be in production as far as in the field or just like on personal projects, would you say that it's a good thing to always keep a separate branch just in case, or is it not necessarily a thing to have all the time?
That's a great question. And I have to break this into two parts. Let me talk about what you all should be doing right now, and then I'll talk about what you all will be doing by the end of the course and professionally. Right now, unless the assignment asks you to work with branches, do everything on main. Especially if you're learning Git for the first time, there's so much happening with the command line and stuff like that. It's not worth the effort, right? It will just become confusing and frustrating. If you have already do have some experience with Git and you want to try stuff out, then you can start working with branches. And so, Devin, to answer your question, um, if I'm working just by myself, I'll just do stuff on main. If I want to try out an experiment, I might go on another branch. But professionally on a team and in terms of the workflow to practice, what teams do is the main branch is kind of sacred. Like, especially if you have like 5 to 10 people working on the same code base, the rule is the main branch should always have code that is working and runs right, and you don't do work on it. You always create a branch off of main and you do the work there. And that way, if you make a bug or you have an error, it doesn't happen on main, it happens on my other branch. And we'll see this later in the part 2 of the lecture with what's called a pull request on GitHub, where when my feature is ready, I share it with other people to review, to run automated tests. We make sure everything is good, and then we merge it onto main. Does that answer your question? Yeah, great question. And again, I just want to emphasize for learning purposes, especially for learning Git for the first time, don't worry about that. Like we will get there. Devin, especially if you've worked with Git before other people and you want to try that, go for it. But this is what you all will be doing in the group project for like 2 weeks or so at the very end of the course. You'll be making branches and stuff, so don't worry, we'll get there. All right. Awesome. So let's just kind of do a quick review and then we'll stop and we'll have some more time. So we've covered an awful lot of ground here, right? We've gone over branching. We went over the basics of commits and how commits work. We've seen how to check out branches, and we've just seen this kind of idea of commits in action. And we've done a really deep dive into Git, right? If we go back all the way to where we started, earlier was thinking about Git on my computer versus on GitHub, which we'll talk about in part 2 of the lecture. Creating a Git repository with the Git command line program with Git init. Adding code, understanding the workflow and the 3 statuses of code in a Git repo, untracked, staged, or committed, right? And we saw how to add or stage changes we make to code, then how to commit those changes. And we've gone beyond that and gone much deeper into Git to really understand about how commits work and branching and things like that. Now I have a couple key bits of advice, and let me kind of roll all the way down to the very end. First off, we have a cheat sheet here and linked at the bottom. You will want to need a cheat sheet. Second, most things in coding, I'm going to tell you just run the code and see if it works. Try it. Even if you're not sure, try writing code before you go back and review the video. With Git, you have to be a little careful. With Git, come to a TA or an instructor if you're not 100% sure about what you're doing with your Git command. Certain things can cause real problems. The classic one is a repo inside a repo. Like, let's say I make a directory, and now I go inside that directory, and I either clone a Git repo into here by mistake or create one. This can end up being super confusing. And other things can be confusing with Git as well. So if you're not 100% sure about what the Git command you're running is doing and why, slow down, take 10 minutes, review some docs. If you still don't feel 100%, reach out to a TA or an instructor. Related to this, never ever run a Git command that you just copy off the internet. With some code from Stack Overflow, you should always read the code and understand it, but it's a little less risky. With Git, you can really paint yourself into a corner and create a mess. The Git status command is your best friend. You should be using it all the time. And then finally, focus on using Git on the command line because it will help you get comfortable on the command line. And again, I know a lot of really talented software engineers who are not command line wizards, especially in the Windows ecosystem with C# and things like that. It's not as needed, but they're all comfortable on the command line. And so this is building up fundamental skills like practicing free throws in basketball. Right? So ask for help sooner rather than later. And then again, here in the curriculum, we have a cheat sheet. And if you search here for Git, you'll see a lot of resources, including that cheat sheet that has a lot of just notes and some examples and stuff. So that's it. We are off to the races with Git, and then in part 2, we will see how we share code from the Git repo on my computer on GitHub. All right. Thank you, folks. Now let me stop our